Hello, I'm Charlie, and this is a demo of the Chrustler here on the right. On the left, I've got SP404, which will just serve to demo how the Chrustler works in the context of a larger setup. The audio out of this is run into the input of this, and vice versa. And I've also got a USB stick plugged into the Chrustler for saving and loading samples. And the Chrustler is booted with its default parameters: C major, middle octave, triad type chords. The high and low frequencies, controlled by the time of flight sensor, are set to their default maximum values, and the gate is off. So let me go ahead and record a sample here. We'll make sure that the audio input is set to internal, so that we'll use the speakers and the microphone here. And let's record. And it will do some processing, and then we can play back on the internal speaker. It's a little quiet and low, so I can increase the octave. And this F key plays the fundamental note of the scale, so in this case C by itself. That doesn't sound too bad. Make it a chord. Turn the volume down a bit. And that sounds pretty good. So this top knob does both volume and the I/O control. So if I hit this again, it will go to the external, play through the SP, and you'll be able to hear it a little bit better. So let me switch things up a little bit. We'll go C minor. We can change the type of chords to sevenths or ninths, but we'll go with sevenths for now. And then I'll go ahead and set a low pass filter. So the low frequencies will be high and the high frequencies will be low. And we can sort of lock that in by turning the time of flight sensor to off. It cycles through high frequency only or low frequency only. And then you can put on some drums from the SP and try and make a music. Shift the octave down. Might sound a little bit better. And so that sounds pretty nice. I'll set the gate to turn the sound from the Chrustler off. With the gate on, when you release the key, it stops playing. And I've also prepared another sample here that we will try and turn into an instrument on the Chrustler. So I'll go ahead and start recording. And let's see how that sounds. Oh, a little quiet. And it does come back with the same values that you had before, or the parameters. And let's also turn these guys up. And that sounds pretty nice. I'll turn the volume up just a little bit more. And we can go down to the low octave. That might sound cool. And turn the gate off. We'll set it to a different key, maybe G sharp major. And that sounds pretty cool. So I also want to show that the time of flight sensor is intended to perform with. So if I just hit this one chord, probably can't see the values on the screen too well. I'll try just using one finger. Or maybe go up so there's higher frequencies. And I will play a few chords into here and make something of a final beat. All right, so what I ended up deciding on is I did a 1, 6, 3, 5, and I did 1 and 3 in the high octave, the 1 and the rest of the chords with ninths except for 3, which was 7th. The high frequency just wasn't quite right. And so we get something like this on there. The 6 was down an octave. 3 was in the high octave with 7ths. And then the 5 was in the middle octave with ninths again. And, oh, I guess I accidentally hit something. And when we put that together in a song here, or just with some drums, not really a song. And you also hear that while I'm playing, I'm doing a swell using the time of flight sensor. And it's subtle, but it adds a nice humanization since it is a very digital electronic instrument. One more thing is that I can reload any of the samples that I've recorded like this. So if I go back 39, and there is our vocal sample from before. That's with the sound. You press the encoder, and I have a bunch of stuff recorded in here. And it's all loaded from this USB stick. You'll see if I select a sound, it starts flashing because it's read the sound. Oh, that one didn't sound good. I've messed around with this a little bit, but that's it. Thank you very much.